Hi, now we are going to see Northern Shore Protocol version 3. The previous session we were seeing about Northern Shore Protocol version 2. That is, it was impersonated by X, and actually X has replayed the information which was already sent between A and KDC. So this is what the problem we faced with the version 2. How are we going to avoid in the version 3? So if you take this version 3, what happens is, see, only one change they have made in the version 2 and the version 3. That is, if you take this first message, they have added this R3. It is nothing but the random number or the nonce which is generated by A to check the freshness of the message. See, A comma B comma R3 is sent by A, and if you see in the replay message, this R3 is also added. Why they have added this R3? Because now A will come to know that this is the message, this is the replay message for the message 1 which it has sent to KDC. Now, as we have seen in the version 2, nobody can use the old information or replay the same messages which was communicated between KDC and A previously. So, the difference between the first version 1 and version 2 is we have added this B. In version 2, we have added this B in order to confirm that this is the person with whom A is going to communicate. And in the version 3, one more change we did in the protocol, that is this random number R3 in the message 1 as well as the message 2 to show or to prove the freshness of the message. Next, as usual, all the others are going to be same. This portion I forgot to explain in the last sessions. This rounded portion is nothing but ticket. So what is ticket? Ticket is nothing but the information which says to whom it is going to communicate, to whom B is going to communicate, and what is the session key that has to be used by the B to communicate with the A. So this ticket is entirely for this ticket information is for the B, which is encrypted also with the long-term secret which is shared between only B and KDC. So this ticket along with the session key information which is intended for A is sent, and the to whom this message is, that is B, and the random number for checking the freshness. These all informations are again encrypted with the long-term secret of A which is shared only between the A and KDC. And as usual, there is no change in 3, 4 and 5, fifth message which we have seen in the first and the second version. See, same ticket is taken and it is attached along with the challenge which is given by A to B to prove its identity. So EAB of R1, AB is nothing but the session key which was sent by the KDC to A to communicate between A and B. So EAB of R1 is decrypted by B, and it takes out the nonce and it will decrement it by 1 and it gives the response as R1 minus 1, and it also has to give the challenge to A to prove A's identity, to check the A's identity. So it gives its own nonce called R2. Now it is the A's turn to prove its identity by decrementing the challenge which was sent by B to A. So what is the challenge which was sent by B to A? That is nothing but R2. Then A takes R2 and decrements by 1, that is R2 minus 1, and it encrypts this R2 minus 1 with the session key which was given by the KDC to A and B, and it sends it to B. So this is how the version 3 works. But what happens here? What is the disadvantage in this also? What the attackers can do with the version 3 also is, see, now A has communicated with KDC previously, and what happened, we'll consider that at 8 o'clock A has sent message to KDC that it wants to communicate with B. So KDC also generated session key for the communication with B called KAB, and it has sent. So 12 o'clock now, A finds that A's long-term secret has been stealed by X. So what it is going to do? So when it comes to know at by 12 o'clock, when it comes to know that it is stealed by X, it immediately informs KDC to generate a new long-term secret for it, that is A. So this will take some time. That is, if 12 o'clock it realizes, then to generate the new long-term secret for A, the KDC will take some time. We'll assume that let it be some 10 minutes. Within the 10 minutes, after acquiring the long-term secret of A, what X can do as an attacker? So what X is going to do? See the first message. So only A and KDC knows that A's long-term secret has been compromised now, but B doesn't know that A's long-term secret has been compromised. Now X takes the opportunity and it sends the message. What is this message? This message is nothing but the replayed message. This is nothing but the old message which was sent at 8 o'clock by KDC to A. If you take this A dash, what is this A dash? It is nothing but the long-term secret before the compromise. That is before 12 o'clock. So it uses the same information which was shared with the KDC to A and it sends that same message. So B thinks that it is the message from A and it takes its own ticket. That is, this is the ticket. This is the ticket which is for B, which gives the session key information and to whom it has to communicate. So it takes it and it gives the response to the challenge which was sent by X. Actually, B thinks that it was sent by A, but it is sent by X, and it proves its identity by by giving the response by decrementing it by 1, and it gives its own challenge, that is R2. Next, X will again prove that it is authorized by decrementing the challenge which was sent by B, that is R2 minus 1, which is encrypted with the session key. The session key is nothing but this old session key, but this doesn't know. Our B doesn't know that it is the old session key, and they are using it to communicate. And whatever the communication after this authentication process happens between X and B is not known to A and KDC. Even B doesn't know that it is communicating with A. It is thinking that B will be sending the messages and communicating or exchanging the messages with X, thinking that it is communicating with A. This is what the disadvantage of version 3. Now, how we are going to avoid this type of attack in which X impersonates A to B. In the version 2, we said X impersonated B to A. And here X impersonated B. X impersonated A to B. So this is how it works. Next, so in order to avoid this type of attack, they have invented a new version, that is Needham-Schroeder protocol version 3. Final version. So which gives solution to all the problems which was undergone by the version 1, 2 and 3. See the message, the first message, A comma B. So A is sending to B that I want to communicate with you, that is to B. And in the second message, B is sending to A that this is the challenge. R4 is my challenge, which is encrypted with the long-term secret B. By this you will come to know. See, this B is nothing but the long-term secret of B, which is known only to B and to the KDC. So this message is not intended to A. It is intended to KDC. So A will send this information, that is EV of R4 to KDC. Along with that, it also will give the R3. What is this R3? That is its own challenge to KDC to check the freshness. Because in the version 1 we saw that it has been changed by somebody else. In the version 2 we saw that the old message was recent. In order to check the freshness of the message, this R3 is added by A to KDC, and this is added by, this is the component which came from the B to KDC. So from this B will come to know that who wants to communicate with whom at this time and what is the freshness of this. So A and B will be knowing that this is the fresh message with the help of this R3 and the R4. Next. So now KDC, it is the responsibility of the KDC to generate the session key for the communication between A and B. So it is generating the session key called KAB. Its responsibility to inform A as well as B about the session key which it has generated. So to A it is informing with this information, and to B this ticket is generated. To inform B, this is the ticket which is generated by KDC and it is sent to A. See what the ticket contains now. See EB. B is nothing but the long-term secret which is shared only by B and KDC. And A, why they have included A? It says that B is going to communicate only with A, not with anybody. And KAB is nothing but the session key that is used for the communication between A and B. And R4 is this indicates the freshness. So in the second message you would have seen the R4 here. For that message, this is the session key. So this proves the recentness or the freshness of the message. And again by R3, A will come to know that this is the response of the previous message which is sent and not the older one. It is not the response of the older message. This is the response of the recent message which it has sent, because the value of nonce is same in both the messages. This is how both A and B will come to know about the freshness of the message. And how it is going to replace. So our key exchange part is over. Now the authentication part is going on in 5th, 6th and 7th. As we said, the ticket has to be taken and it is sent in the 5th message, and along with that it is A's responsibility to give the challenge to B, which is encrypted with the session key, and now B is giving the response and its own challenge to A, which is again answered by A by sending its response. Response is nothing but decrementing the challenge by 1. What is its challenge? That is R2. It is decrementing R2 by 1 and encrypting it with the session key which was generated by KDC. Then it is sending to B. Now after this data exchange part and the key exchange part and the authentication part, the communication between A and B will take. How they will be communicating? They will be sending the messages which is encrypted with the session key which was generated by the KDC, that is KAB. Until the session gets over, this session key will be valid. After that, it will not be valid. If they want to communicate once again, they have to inform the KDC that we want to communicate, and they have to request KDC to generate a new session key. This is how Nedum-Schroeder protocol version helps us to get the session key and provide the authentication between each other. Thank you. Thank you for watching.